Everyone open your note packet. It is unit 2.2 and go to 1.0. Topic page number is page number 2. Okay, so in this unit we are going to learn covalent bonds, okay, covalent compounds. So last topic we learned ionic compounds. Let's go ahead and review that first. Okay, why atoms are forming bonds? We know that to get stability, to attain stability by getting how many electrons there? 8 electrons in their valence shell. ES means electrons, okay? That is called octet. Octet means 8 electrons. So most of the atoms are reacting to get stability either by gaining 8 electrons. There is one more reason we will study eventually. What type of elements form ionic bonds? We learned metals lose electron. When they combine with the non-metals, they will gain electron and that result in ionic bonds. So what happened to the electrons in an ionic compound? So we know that one atom is completely donating. Remember the arrows we are drawing? Sorry. So it is completely transferring from one atom to another. So go ahead and write it. There is a complete transfer of electrons from one atom to another. Transfer of electrons. Okay. Now let's think about covalent bonds. So covalent compounds are formed by sharing electron. Instead of transferring electron, they are sharing electron. So in our daily life or in a real life situation, we are going to see lot of covalent compounds in everyday life. Since you learned biology last year, can you remember few examples? If you can, go ahead and write. The first and most important one is what? It is H2O, which is called water. Our life won't exist without water. And all biomolecules, say for example, carbohydrates. Very good example is sugar. Okay? And proteins, lipids, everything. All biomolecules are covalently compound molecule. If you have a cellulose, paper, wood, your wooden table, desk, everything contains covalent compounds. Okay, so coming to covalent bonding. I'm going to give you a scenario. Okay, if you have two atoms, both of them have 7 electrons. They both need one more electron. Which one will donate the electron? Neither, because they need electron and they are loving electron. We can say they have high electron affinity or high electronegativity. Electron affinity, that's new terminology, but right, it is electronegativity, similar to that. Okay, so neither of them will donate electron, but how they will attain octet then? By doing what? By sharing their electron. Not share, they will share their electron. They will share their electron to get an octet. Say for example, if a fluorine atom which has how many electron? 7 electron, okay? And another fluorine atom which also has the same number of electron. So they will do what? They will share their 1 electron like this. So after sharing, this fluorine got, see how many electron? 8. And this fluorine also got 8 electron. And this is the shared pair between them. That's how they are sharing electron to get octet. So let's go over compare and contrast ionic and covalent bonds. So ionic is formed between what and what? Metal and non-metal. But covalent bond, it is between only what? Non-metal. So you can say that is between non-metals, or is metal and, non-metal and non-metal. Okay, good. Okay, so in ionic, there is transfer of electron from one atom to another. Complete transfer. And in covalent, it is what? It is sharing electron. Okay, and some of the properties we learned about ionic compounds earlier, which is ionic compounds have high melting point. That means it is difficult to melt them, and we will do a lab over this. Okay, high melting point or boiling point. Just try it only melting point. That's good. Okay, and sugar. Say for example, sugar. You can easily melt sugar to make sugar syrup. So this covalent bonds generally have low melting point. There is exception, but generally we are writing only general properties. And conductivity, remember, sorry, ionic compounds conducts electricity in liquid state. When you dissolve or when you melt it, they will conduct electricity. Reason we know that they have what? Ions in it. But covalent bonds never do what? Never conduct electricity. There is an exception, which is graphite. Everything else will be insulated. They will never conduct electricity in liquid state or in solid state, both. Okay, so those are the properties, and I am going to teach you how to name them. Remember, ionic compounds naming, there is a totally different rules for covalent compounds. Okay, so covalent compounds use prefix to show how many of atoms are there. Because we can't do crisscrossing here, we are not using charges. So we have to tell other people how many atoms of each are there. That's why we are using prefixes. Okay. The prefixes you are going to see is this one. Okay. It says carbon and there is dioxide. That di means it is how many oxygen there? 2 oxygen. And mono means how many oxygen? 1. So di means 2, mono means 1. And I'm going to give you the prefixes. Try to memorize it. It is not that bad, okay? Let's go and pick another color. Okay, so the prefixes we are using for 1, it is mono. Di will be, 2 will be di. 3 will be tri. Then 4 will be tetra pack juices, okay? Pentagon, 5 is penta. Hexagon, 6 is hexa. And it is 7 is the new, maybe completely new for it. It's called hepta. And octopus, which is octa. Nona, maybe new for you. And decade, 1 decade is 10 years. So it is deca for 10. Or good. So those are the prefixes we need going forward. And remember some rules also. Okay, my bad. Let me go back, sorry. Okay, some rules also different here. First element, highlighter, come. Okay, first element has a prefix unless there is 1 atom. That is an exception. Never use prefix for if first atom, if it is 1. Say for example, never use mono on the first atom. Second element always has a prefix. If it is 1, you have to tell that is 1A. Okay, let's go ahead and write it. So this one says S4O2. S is sulfur and 4 is what? Tetra. So I'm going to start the name with the prefix, which is tetra. And how many sulfur? The tetra sulfur and a space. And there are 2 oxygens, so I'm going to write di. And oxygen should end in IDE. That is the rule we learned earlier. There is no change in that rule, okay? The second element always ends in IDE. So it is tetrasulfur dioxide. Okay, now let's go back. It says carbon tetrafluoride. It says just carbon. That first element, if it is carbon with that's only 1 carbon. And it's tetra. Tetra means 4 and F is fluoride. So I'm going to write it is F and it is how many times? 4 times. And next one Cl. This is Cl, okay? So write it is carbon. We don't need a prefix for 1 if it is the first element. And chlorine tetrachloride. Okay, next one is penta-iodine tribromide. So penta means how many? 5, iodine is I, tri is 3 and bromine. So I'm going to write I and how many times? 5 times. Bromine, Br, how many? 3. So it is I5, Br3. So next one is tricky, okay? So remember the rule, you'll never start a name with mono. So it is carbon. But second one, even if it is 1, you have to write mono. But if you write monoxide, there will be 2 O's. So I won't write 2 O's there. When you combine them, just skip 1 O, okay? So you are going to write what? It is monoxide, not monoxide, okay? It is monoxide. Okay, that is it. Now everything is yours, okay? Go ahead and do this. Okay, so you may confused here. Here it is decoxide means it is decaoxide. Pentoxide means pentaoxide. Heptoxide means heptaoxide, okay? So if you have A and O together, we will skip A. That is decaoxide. When you combine them, you will write decoxide. Okay. Remember that. Don't get confused. Okay. So I'm going to do one example for you guys. Then rest of that you have to stop the video and finish every other questions. And the rest of them will be a review next class. Okay. So I'm going to do number 1, which is carbon dioxide. Okay. And do maybe 1,4. No. I'll do number 5, which is dinitrogen. Pent means how many? Pentoxide. Okay. Now stop the video everyone and do 1, 3, 5, 7, 9. Then do number 11, 13, all odd numbers. Do all odd numbers. You can stop the video for 10 minutes, okay? Then do that. Once you're done, unpause the video and go here, okay? Here it is a combination of ionic and covalent. The same thing, do all the odd ones, okay? Rest of them we will do it. And the only one thing you have to remember, if you see a metal and non-metal, that will be ionic. Remember, metal, non-metal will be ionic. And if there is non-metal, the non-metal will be what? Covalent. But this example, this one has only covalent. You can see nitrogen is covalent, hydrogen is covalent, P is covalent. But there is a polyatomic ion. If there is a polyatomic ion, I would go with what? Ionic. If the polyatomic ion is the beginning, I would go with ionic compounds. Okay, otherwise you will get confused. If you are confused on any of them, skip that and we will discuss next class. Okay, so do all odd question. You will get again 7 minutes to do that. Okay, so the rest of them is also extra practice. We will do that next class or as a homework. Okay, and I am going to the type of covalent bonds. Once you're done with that practice question, just start this one. Okay, so type of covalent bond. We said covalent bond is formed by sharing electrons. Okay, so sharing electrons, they may share one pair, one electron pair or two electron pair or three. There are three type of bond. If they are sharing one pair, that is called a single bond. We will draw one line to show that. They are sharing two pair, that is called a double bond. Right bond everywhere. Okay, it is drawing two lines. See? And if they are sharing three pairs, which is called what? Triple bond. Three lines. So bond represent the pair of electrons or number of electrons being shared. Which will be the strongest bond? You can see this is a triple, like this is double, this is single. Use that example, which will be easy to break. A will be easy to break because there is only one layer. So, if there are more strands, it will make more stronger rope. The same thing, more shared pair of electrons will make a stronger bond. So, which bond contains most shared electrons? That will be the strongest. So, which one is that? Because the triple bond contains more pair of electron, that will be what? The strongest. So, one more time, there are three type of bonds: single, double and triple. Single will share one pair, double will share two pairs and triple will share three pairs. Okay, so this is a review of what we learned previously. On the coloring of periodic table, we said some of the elements will exist as two. They are called diatomic. And we colored the periodic table. These are those 7 elements. High 7. So those are always exist as two elements, okay? They always exist by forming a covalently bonded molecule. Okay. Now I'm going to show you how to draw the covalent bond. Okay. So here we can see this chlorine has 7 electrons. Okay. This chlorine also has 7 electrons. So they both need one more. So they will, if they need one more, they will share one pair. So they are sharing one pair of electrons. So which will result in what bond? A single bond. So they all have 7 electrons. They need 8 by sharing one more pair. Okay, let's do the Lewis dot. This is Lewis dot drawing for different examples. These are the rules. First you have to do what? First you have to find the total number of valence electron from both the atoms and decide which one goes in the center. Always on your periodic table, if you have these two, this one will go in the center. Always the left side atom will go in the center. Exception, hydrogen, since it's too small, it can't go in the center. Okay. So, Always atom with the less valence electron, which is the left side atom, which will go in the center. Okay, so I have to charge my pen. We will record after that. Okay, so let's continue. Usually, the atom which is on the center will have less number of valence electron, okay? So less number of valence electron. Only exception, hydrogen never comes in the center. Always remember, hydrogen is small. It cannot accommodate so many atoms around it, so it will never come in the center. Okay, first you have to decide the central atom, then join all the atoms with a single bond. Remember, one bond means how many electrons? 2 electrons. Then once you're done, place the leftover electrons in pairs to the surrounding atoms first. Start with the outside atom, which is called surrounding atoms. Then fill the central atom. Remember the exception, hydrogen need only 2, and there are 2 other exceptions you need to be worried, which is beryllium, which has only 4 electron needed, and boron 6. They all doesn't get 8 electron because of their small size. I would say that like that. And after you doing this, if you don't have enough electrons, then you have to move the pair of electrons to double or triple bond. Don't worry about the rules. I'm going to show you that how to do it. Okay. Let's practice. First one, CH4. Okay. So first step, what is the first step? You have to calculate the total number of electrons. So I'm going to show you how to calculate the total number of electrons. So carbon is in 14th group. Here it has 4 valence electron. Carbon has 4 electron. Okay. And how many carbons here? There is only 1. So you will multiply with 1. Okay. Plus there is one more atom, which is hydrogen. Hydrogen has only 1 valence electron. And how many hydrogen you have here? 4. So multiply with the 4. Then solve this. 4 times 1 is 4. Plus 1 times 4 is also 4. So total how many electrons we have? We have 8 electrons. Don't have space, all right here. So we have 8 electrons. So decide the central atom. I said always the least number of valence electron will come in the center. So hydrogen is the least number, but exception, hydrogen will never come in the center. So carbon will come in the center. So I will write carbon in the center, and this is a central atom. I would label like that so that it will be easy for you. So this is a central atom. This is the surrounding atom. Surrounding. So first write the central atom, then write the surrounding atom, surrounding like anywhere. Okay, I would do like a 90 degree right now. Then we will learn how to put that in correct shape. Okay, just draw single bond. That is the next rule. First write the surrounding atom, then draw single bond. Remember, each bond is how many electron? 2 electron. So let's go ahead and count it. You don't need to draw it, but now I'm going to draw it so that you will understand. Okay, so there will be 2 here, 2 here, 2 here, 2 here. So we had 8 electron. We had 8 electron. And I used all 8 electrons. There is nothing left over. 0 left over. So now we have to check whether all the atoms are happy or not. Okay. So hydrogen needed only 2. This hydrogen has 2. This hydrogen has 2. This hydrogen also has 2. This all hydrogens are happy. Now look at the central atom. Carbon, there is how many? 2, 2, 2, 2, 2. The carbon also has 8 electron. hydrogen is also has 8 electrons, so they both are happy. So our structure is happy. I am happy, you are happy. Okay. Okay, let's go do the next one. OF2. First step, calculate the valence electron. Let's do it. So for calculating valence electron, we are going to, I'll use a different color for calculating. That will be good for you. So oxygen has 6 electron. And there is only one oxygen, so I will multiply that with 1. Okay. Plus fluorine, which has 7 electron. And how many fluorines you are seeing here? 2. So total electrons are 6 from the first one. 7 times 2 is 14. So total how many electrons? 20 electrons. Okay, now decide the central atom. Oxygen has 6, fluorine has 7. So least number is oxygen. So central atom is what? Oxygen. Oxygen is the central. So I'm going to draw oxygen at the center. And there are 2 fluorine. So put fluorine anywhere around it. Okay. I'm going to draw like this. Okay. Now draw a single line to both of the atoms. So now we have to make the surrounding atoms happy. So here we have 20 electron here. We used how many? Only 4. We used only 4. So 16 electrons are there. So I'm going to give, there are already 2, it needs 6 more. I'm going to give the pair, which is called a lone pair, because they are alone. They didn't share with anyone. So there are 3 lone pairs. So that fluorine is happy. So I used 6 from there. So I have 10 more. I'm going to do again 6 here. So that also happy. Okay. So now we used 6 plus 6, 12, 2, 4, 16. How many more remaining? We have 2 more remaining. Okay. Check whether all the atoms are happy or not. Okay. I'm going to check it. This fluorine is happy because it has 8 electrons. This one is also happy. But look at oxygen. Oxygen has how many there? 2 from here, 2 from here, there is 4. So we have how many? We used 8 here, 16. We have 4 more. So I'm going to give that 4 electron to what? Oxygen as a lone pair. I'll do on both, same side. So now oxygen is also happy. So both the atoms are happy. So that is a stable compound. So I'm going to write oxygen has 8 electron. Fluorine also has 8 electron. So they both are happy. So the structure is correct. Okay, so those who want to label that the pair of electrons, so the pair of electrons, those are called, this pair, all these pairs, they are called lone pair. If you want to write that somewhere, because they are alone. Okay, let's do the next example. Again, calculate the valence electron, which is the first one. Beryllium is in second group, 2 electron, and there is only 1 beryllium. So it is 2 times 1. Plus hydrogen, there is 1 electron, and so 1 times 2. So total how many electron? They have only 4 electrons. Okay, so decide central atom. Hydrogen will never come in the center. Beryllium will come in the center. So beryllium is the central atom. Okay, there are 2 hydrogens. So write hydrogens like this. Okay, now draw a single line. So we had only 4 electrons. So I'm going to check how many we used. Each bond is 2. There is 2, 2. Already how many we used? We used 4. Now check whether all the atoms are happy or not. Okay. So this hydrogen has how many? 2 electron. Hydrogen need only 2. They are happy. And beryllium has how many? Beryllium has 4. See, those are the exception we wrote earlier. Beryllium need only 4. So hydrogen has 2. They is happy. Beryllium has 4. That is also happy. And our structure is correct. Okay. Let's do the next one, which is NH3. Okay. NH3, calculate the valence electron first. Nitrogen has 5 electron. There is only 1 nitrogen plus. Hydrogen has 1 electron. There are 3 hydrogen. So it is 5 plus 3. How many electron? 8 electron. E minus means electron, okay. Then decide the central atom. Hydrogen will never come in the center. So nitrogen in the center, write nitrogen. And there are 3 hydrogen, write hydrogen around it. Then draw single bonds. Now we have to check we have how many electron remaining. So here we used 1, 2, 3, 4, 5, 6. So we have 6 electron remain, 2 electron remaining, okay. So I am gonna check whether hydrogen is happy. Yes, hydrogen is already happy now. Then look at nitrogen. Nitrogen has only how many now? Only 6. And we have 2 more remaining. So I will give that 2 more electron to nitrogen. So now nitrogen has 8 electron and hydrogen has 2 electron. Both of them are happy. So the structure is correct. Okay. Okay, let's do, you are doing this as a homework. This will be a homework. I'm gonna do this one. It's a multi-electron atom. You will get confused how to do this. Let's calculate the valence electron first, okay? So carbon, there are 4 electron and 1 carbon, okay, plus hydrogen, 1 electron, there are 2 hydrogen, plus fluorine, 7 electron, there are 2 fluorines. So it is 4 electron plus 2 electron plus 14 electron. So it is 14 plus 2, 16 plus 4 is how many electron? 20 electron. Okay. So now there is hydrogen, fluorine and carbon. Carbon is the one with the least number of electron. Hydrogen will never come in the center. So I would draw carbon in the center. Okay. Then 2 hydrogen. So go place 1 hydrogen here, 1 hydrogen here and 2 fluorine. 1 fluorine here, 1 fluorine here. Then draw single bond. So we had 20 electron. We used how many? 2, 4, 6, 8. So we have to make fluorine happy because fluorine has only 2 and we have a lot of electron. So I'm going to use 2, 4, 6. So that fluorine is happy. 2, 4, 6. So now check all the electrons, okay. We had 20, there is 2, 8, 10, 2, 8, 10. We used everything. We don't have any electron, okay. So let me check hydrogen is, let me check whether all the atoms are happy, okay. So hydrogen has 2, fluorine has 8, this fluorine has 8, hydrogen has 8. Okay, let's look at the central atom. Carbon is also having 4 bonds, so 8 electron. So carbon 8, hydrogen 2, fluorine 8. So everything is happy, so structure is correct. So rest of the class you are finishing all these boxes and we will check the answers next class.